Hi, Winston.
Hey Jack.
Hi, you're mobile, huh?
Yeah, no, because I usually have the meetings near my desk. It's an open area. Somebody else is already having a meeting, so I better grab a room. So
Sounds good.
uh, before the other guys hop on, uh, yeah, I think Andy and Kinshuk and the team have been making progress on the hierarchical example. So they'll
Mhm.
reach out next week to you and Wei Feng and Yasha to maybe Tushar as well, right? To just like walk through that example. So see what everybody think.
That would
Okay.
be great. That would be great.
Hi, good afternoon, everyone.
Hi.
All right.
Yeah, sure, we have to find some time to catch up. It's been a bit busy, but maybe next week I'm back in Boston and I have some time.
Okay,
Jack.
sounds good. I'm at a conference next week, but I'm sure I
Oh,
can find like half an hour or something to find a quiet spot on the side somewhere.
okay. I'll
Um,
send you some times. And I think, Jack, I think you and I should catch up before you head out as well.
Okay, sounds good.
Hey Jack,
Hi. So we'll go through some logistics and then we can talk about how we want to kind of do global summit, you know, some pieces. I wrote a draft of a blog. Rob said okay, so we can kind of go through whatever you'd like to go through.
okay, sounds good.
Yeah.
I have not read the blog yet, Jack. If I have some time, that's on my plan for this weekend. I don't know what your timeline is.
We just last year, I think Wei Feng and I got it up end of September kind of thing. So if we sometime over the coming weeks we agree on what we want to say, how we want to do, what we want to add, however it goes. Then it goes into Rob and team for review, and once they're okay, then we just get it posted, and then from there, I know everybody just kind of posted to LinkedIn, kind of thing, so it kind of spreads the word and some of the pieces going on. So, you know, and as I told Yasha, so in 2 weeks I can do. So I think as Winston was saying, next week we'll talk about infra.proto. We'll meet and kind of go through some things. I have the data services stuff. Actually connected on, I sent mail to Tushar, you know, just started getting a POC running. And so I have some ideas on building some pieces up. But we'll wait for people. It usually takes us about 5 minutes to get started.
Hi, Jake. I added a document. It doesn't have to be discussed here. This is actually in the CNCF community. There's a so-called open telemetry working. So there is interest there to get into like what telemetry is needed, including what I proposed, the aggregate matrix. Yeah, so it's definitely need hardware people to involve. I know may not be in scope for this group, but just want to put it there.
Yeah. So Tushar and I met a couple of weeks ago, and so he knows telemetry is kind of a hot button for me. So the thing that I'm going to when we go through data services in a couple of weeks, uh, I'm actually the part I do for a POC is a shim into the inference space, which allows us to do the data services piece to drive traces. And so since I can't get the traces, as Tushar knows, we're going to build them. And it allows us to actually build inference traces that we're going to talk to the ML perf team. So we'll speak to Oana about driving into AstraSim. So Victor, as you're talking about like with telemetry, telemetry is a mechanism of things I capture. And so we're going to work on what do we want to observe, what kinds of things, what traces do we build, and then from there we'll kind of backtrace into what metrics we capture, how do we actually do some things, what do we measure. So it's top down, bottom up in terms of that space. But I think I've got a path that I reached out to Tushar an email, and I'm going to I have a way to kind of shim into to be totally honest, to shim into VLLM that allows me to actually build data services to drive traces that I can now do AstroSim inference kinds of things on. And so over the next coming weeks, I'm just building some pieces up, working on some of those things. And so I can talk about it in 2 weeks. And, I know Yasha and we're going to whiteboard some ideas, and I have some other ideas that, Yasha and I are going to kind of work through in terms of, mapping DAGs, doing things like that. So we have a couple of things we go through, and matter of fact, I think we may actually, well, it depends on what time it is on a Friday, but I'll be with Yasha. So when we do our next call, I think that's it. Yeah.
Yeah. We'll be here.
Yeah. Yeah. So we can talk about some of the things we're doing. So, okay. So, kind of before we get into the flow and some of the pieces, we're going to get started here. So Kate reached out and said, okay, for this year, because it used to be that everybody brought their own laptop, everybody kind of did their own thing. And she said, this year, the process changed. So I think everybody who was speaking, Syamak, I don't know if you would have got the new order of events. I can forward it to you as well. But we have kind of a new process. So all the PowerPoints are going to actually get submitted. So not only do they get reviewed, and Yasha, as you've asked me in the past, do we have the opportunity to change? So I think all the way till the end of, so we submit for review, but we can do edits all the way to the end of September.
Well, even October, right? They said you can, as long as you bring them the actual copy the day before, they'll still update your slides.
Yes.
Which I think is a very dangerous thing to tell academics.
Yes, because you had asked me in the past, how long can we keep changing? And so typically in the past, they want to see something for review. So I think it's this month that they want to be able to review content and make sure that people are kind of going through, because otherwise, Yasha, to your point, people wait till the very end and now they're flooded with content that's unreviewed the first week of October, and they're never going to finish. And so what we're going to do is the whole OCP team is in Asia Pac this week for the Asia Summit. I have an ask into the OCP team that we're the first two. So we're really a 15 and a 20-minute when you look at the schedule. And so I've kind of, I have an ask into Kate and team. She's our session leader for the breakout, which includes server, includes Nick, includes HPC, and it includes AI hardware software co-design. So to take our first 2 sessions and turn it into a 40-minute session. So we would do 15 minutes with Semantica and team. Tushar would get 5 minutes in terms of kind of, okay, we really set the concept of system of systems. Now we do 5 minutes about modeling, 15 minutes for Yasha to talk about, taking that modeling and building some pieces up. And then 5 minutes for Winston, or I think Kinshuk is the one you had asked, to build up essentially, okay, here's infra.proto, here's the path we're taking, and here's the call to action that, our plan is to move forward in terms of standardizing that path. Jay is in a different track in terms of that. And so now I'd like for us, as a suggestion, to build one slide talking about all the different pieces, and whoever wants to kind of link. I know Syamak has some talks. I wasn't sure if you were system builder. I didn't know where it ended up, Syamak. So it's very hard for me to see all of the sessions. I'd have to go back and look in terms of that. As Semantica said, if you don't know where things are, you can't find anything if you kind of go through and look at the schedule kind of things are. So you have to search by name, search by things, figure out what connects to what and how some things work together. But I reached out to Rob. Rob actually runs the Open Systems for AI. He actually has been kind of working the overall OCP, And I said, our group here would like to put together a blog linking together talks. So, post to the OCP site under the blog that we now can link through for LinkedIn, through whatever other paths that we want to go through to advertise, things like that. And he said that would be a great idea. We just, whenever we're ready as a team, whatever we would like to include, whatever we want to link together. Kevin, I know you're doing some talks. If we want to link all of that together, raise awareness, do whatever, connect into the blog, we can do. I posted a PDF. I can post Markdown, and I have LaTeX. So if you'd like me to convert to Word, I can convert to Word as well. Whatever format we'd like to edit in, I can do. So I have it in Markdown and LaTeX today, but I can convert it to Word if that's easier for us to edit in terms of as an overall space. Or as Jay did, he just sent me comments and said, okay, in this, I would like to change this to this, which I did. And that's in the space that I have, and I'll update those in terms of the pieces that we have. So
if you're looking for some more information thing, we would like to add that converged scale up, scale out stuff. We know our paper was not accepted, but if we can add some of the stuff there, we could, the work we are doing.
So Semantic asked for the link to the blog. I'll send that out to the group, but I can post it as well. And Prakash, to your point, it really just talks about the group and the things we're doing, and then having the talk. So you're more than welcome. I'll post the source, and you're more than welcome to go in and edit whatever you'd like in terms of this, because it's really a group effort.
Okay.
All I agreed to do is, hey, I reached out to Rob, said, would it be okay if we started to talk about what our group's doing, and kind of here's a culmination point of some of those pieces and do a blog? And he said, absolutely. So the first part of the blog, as you would have seen, the draft is like, hey, here's where the group is, what it's doing, what it's focusing on. And oh, by the way, here's at the Global Summit, here's the talk, please come out. We have a call to action on a number of things where we can go through and connect and do some of those elements. And so Prakash, please feel free in terms of that. And Tushar, I know you said your lightning talk with HPE as part of future technology is really not part of it, but we'd like to link to it because it's somewhat related to what you're going to talk about with Semantica and team. So that way we can at least say as part of the blog, and oh, by the way, here's a related thing going through. So now you can see kind of all these things, and people say, oh, okay, I can connect some dots. And so we're going to coax them to connect some dots ahead of time. Okay, thanks, Yasha. So our goal, if it's okay with the team, which makes things much easier for us and to work, is to really kind of we're going to probably stretch a little over 40 minutes, in terms of as we go through, but to submit one PowerPoint that we actually can set the tone on system of systems, talk about modeling, an example of modeling, things like this, and specific in the compute environment, and then do the call to action on the schema, going through in that, and then link to some of the other talks as we actually go ahead and do some of those pieces. So that's really the goal, and that's the ask we have in. If somebody objects to that right now, I can work, because I won't speak to Kate until next week. Weifeng and I won't speak to Kate until next week when they get back from Asia. But that's essentially kind of the path, and that allows us to maximize the time. Otherwise, we have to transition in some weird way. The part that's on our favor is the OCP leadership asked to have longer talks, which actually built concepts up, versus when we actually went forward with our breakout session reviews and what to accept. If some of the people who've traditionally done this for a long time, if they could have done 5-minute talks, we would have done all of them as lightning talks. And that would have been a little bit obnoxious because we'd have been just transitioning the whole time. So this allows us to bring some continuity to some pieces. So I can open the floor for a minute for anybody who objects. Otherwise, we can kind of go through from Semantica and Matt, from Tushar, from Yasha, and from Winston. And I don't know if King Shuck's on. I don't see him, but Winston, talk about kinds of the things that we'd like to talk about as we go through. After that, I can kind of bring up the blog, but we can open the floor. I know Kevin's on, and I think he's doing some talks in another space. And
I did put in for a couple, but they didn't give me anything as far as I can remember.
Okay.
But somebody put me on a panel for something else.
okay. But, Kevin, with the blog, if we'd like to just really talk about kind of some of the things where some pieces are connected, and I know I've been rude about this in the past, but we do have somebody who reached out to us this week. So Chance, if you'd like to do a quick intro, and then we'll get started.
Can you guys hear me?
We can hear you.
So yeah, thank you all. My name is thank you, Jack, for the introduction. So yeah, my name is Chance Graves. I'm actually my background is more so in hardware systems engineering. I spent previously a lot of time at Intel. I worked a lot with OCP partners like HW Design Solutions, mostly on server design. And I worked with Meta and some other customers with some of the reference design as well. I'm actually going to be joining Cadence as a product engineer. I'll be working a lot with the emulation and the design platform for the pre-silicon environment to test and configure the hardware silicon the definition for a lot of customers in the Bay Area. So I reached out to Jack to learn about this AI hardware software co-design group, and I was really interested to learn more about what the community is offering. And I'm here to just meet the rest of the community and see where the projects are progressing on.
Okay. And so, Kevin, that's why I connected you. It's part of the whole EDA space. So as we kind of brainstorm on some things, that'd be great. So, okay.
Good.
Thanks for joining. So, so Semantica Matt, we'll kind of walk through, I wanted to use today's session because if we waited 2 weeks, we would have 2 days to, you'd have only the weekend to actually finalize slides in terms of this. So this gives us a, if there's any sort of suggestions, things like this. I'm not expecting, there was no expectation that slides would be done today, but it just kind of gives us a way for the group to kind of, as we're going to build one slide deck to talk about who's doing what kinds of things, how do we want to transition, where do we want to connect some dots. And so, in the interest of the group, I will go on mute and off camera so that we can actually have a dialogue versus a monologue from Jack.
So, when we have a couple of slides, we don't have to walk through all of them, but I can just quickly fly by, and they're probably way too many for 15 minutes anyhow. But how does that sound okay? And you guys can give some suggestions, and then I do want to talk about how we transition from this to Tushar. Any slides that you might have on the modeling.
Yep.
Okay. All right. So let me bring this up. Can you guys see the slide coming through?
Yeah.
Okay, all right. By the way, is there a template that OCP requires, or we can pretty much use any?
Yeah, they did send a template over.
Oh, they did?
Um,
Okay.
yeah.
In the email?
Oh, I don't know, but I have it saved. I downloaded it so I can send it over to
Yeah,
you.
please do email it. I'll import these over there. So this is the title of at least our talk, our piece. And then if we are building this all up into one, we can maybe, what I was thinking is either have a larger title and then subtitles for the pieces, or so we should coordinate on that. So here's how I've broken it up. A concept, couple of slides, two to three use cases for the system of systems, and some of the infrastructure and architecture considerations. This is what our abstract focused on. And then, simulation frameworks. I have a slide that we have used in the past, but Tushar, we should see how we segue from this to that. Okay, so this is our concept of macro heterogeneity. What it is at a data center level, it is this notion of many systems connected together in a loosely coupled manner, HPC, AI, private science cloud, commercial clouds, IO-based systems, all connected with an advanced technology network, right? And the focus in this type of a system of systems is, multi-tenancy, virtualization, containerization, because you're really focusing on the cloud piece. What we're trying to drive, at least at HPE right now for this, we're doing both, but from the perspective of the tightly coupled macro heterogeneity, it's creating partitions that look to the user like a single system of systems. So the difference between these two is that you can have many systems. Each might be a GPU-based system, a CPU-based system, a specialized accelerator system. It can have its own internal fabrics that are recognized, but they all tie in together through a very tightly coupled network and data sharing framework. There are options for this. So I try to, we of course have some options internally. We have Slingshot that we use for networking at HPE. There are other options. I think we want to lean in very heavily on open standards to do this. So I put UEC as something that would be our open standard. The goal would really be to be able to try to couple mod sim, modeling and simulation partitions with AI or even quantum partitions, right? Tomorrow, if quantum comes aboard, bringing that forward. Stop me. I'm just going to fly by. Like I said, I have a lot of stuff. I don't want to take all the time. I just want to take 10 minutes and then hand that over to everyone else. So this is our framework for this goal of macro heterogeneity. This is a different way of looking at the same picture without the clouds, how they would all work together. This is an example of a heterogeneous system of systems that's actually installed in Jülich Supercomputing Center at Germany. It's a very different approach, but again, same goal. There is a GPU cluster, a CPU cluster, some storage, and potentially some future quantum and neuromorphic clusters that they want to enable. So use cases for the system of system, and I have 3 slides with real world use cases, but at a very general level, it's if you have a larger complex application where you want your inner kernels replaced by surrogates and have the inference queries come in from the actual simulation partition, or you want, say, a multi-physics coupled application and AI is steering and syncing the jobs. And this is a slightly different or a newer one where everyone uses real world data to train for AI. But what if we don't have that because you have newer use cases? Maybe you can actually simulate something and use that as training data for AI. So very quickly, these are 3 use cases that Matt has been looking at and focusing. Climate modeling, classic use case where you have different models in your ocean, ice model, atmosphere model, and we can replace maybe a fog model or an atmosphere model with AI surrogate. Combustion modeling, again, fluid dynamics, classical thing where it runs better on certain types of hardware, whereas so other parts of the physics runs better on a CPU partition. Intelligence gathering, right? You're collecting data from random sources, sparse data, unrelated data. You want to be able to process this, put it together in a usable manner, and then have this flow into mini systems that can work on different pieces of it. So here are the use cases. Let me just pause, see if there are questions. The next couple of slides are some of the software pieces we're exploring, the profiling tools to understand how to use a system of systems, and then the simulation slide that will segue into Tushar's work. No questions? Okay. Part of the challenge of a system of systems is not just hardware, it's the software, right? Being able to run all these systems together and have them look like one requires some, interesting runtime, like newer innovations in the runtime. So a few things that we're looking at, Dragon HPC is an open source project that HPE is working on to look at this. This is an example of maybe some profiling tools that we might need in future. Again, kept it very general, right? We have some internal tools, but whatever, this is something that would be great to do and have it be open source so people can add and contribute to it. And then this is what I was.
Samantika, I have a question.
Oh, yeah, go ahead.
So I think one of the challenges is in a system of system is learning the topology and the characterization of the different components in the topology.
Mm-hmm.
In the tooling, and I was hoping that something will pop up. Is there any such tooling which you have? See, I'll give you an example. Let's say a simple example. If you're running a AI ML workloads, right? Today, the topology is contained within within a GPU system, etc. Right, and then it's extended to the network, local scale up or scale out, etc. And then the Slurm or Kubernetes, whatever you're using, does the job placement based on the optimal performance for a given workload, right?
Yeah.
Now, same problem gets amplified, like you had these different components, which are either CPU centric, GPU centric. Now, first thing is you need to know what your system of system is composed of, the composition, what is the characterization of it, and how does it map to the different workloads. And I was very curious to know that, is there some work which you already have or you're thinking of?
So this is part of our profiling tools. First part of it is, okay, how does it map to which type of compute would it map to? And yes, we have some internal tools on that. The topology piece, maybe you're saying something different, which is you want to understand. I wasn't envisioning us doing any profiling tools to really identify what topology it would work best at. If I understand topology the way you're saying it, this was mostly, well, what partition or what mini system do you map well to based on the characteristic of the workload, right? And here are some examples that Matt listed that we put in there. But perhaps it's also valuable to have a tool that can learn what's the best topology. The thing is, I think the topology would be decided. I don't know, Jay, maybe you want to explain a
I
bit more
think
what you're looking
there's
for.
Yeah, I can explain a little bit, not just the topology, right?
Yeah.
I mean, you have different
You're talking about
components.
scheduling, because we do have that work, which is what's the best way to schedule this across the system. That I do have, but not something that would dynamically do any topology changes.
Not changes, learning, basically. Like,
Yeah.
let's say that you are running a Dragonfly topology. It's a
Yeah,
Dragonfly
yeah,
cluster,
yeah,
right?
yeah.
Within the Dragonfly cluster, you want to have a localization within the group ID, right?
I see what you're saying.
So just and somebody may not, your weather forecasting may not have a Dragonfly. It may have a factory topology.
Yeah. I think I agree with what you're saying. I will expand this to not just focus on the compute, but also on the network piece of it.
No, I think even on compute, the same problem, as the compute, you're scaling up the compute too, right? Your compute server rack is now a combination of GPU and the CPUs with the interconnect, right? And there also you want, and then you may have storage. Let's forget storage for a minute. You have a memory cluster, right? Or you have a high bandwidth memory pool as a separate tray.
Okay.
There's a couple of different graphs. One is the software and what it's doing, and the other one's the hardware you have available. And it's trying to map one graph onto the other. And if you've got the software running, you can look at how it's performing and what's critical to it.
Yeah.
So it's a question of some metrics and then using the metrics to make best use of the hardware.
And I think that's one, maybe, what I really want to do is generalize this, and, telemetry would be a big part of the system of systems, right? Being able to collect it to understand efficiency, utilization, and have that feedback into future system architectures, I think is key. So this is the start of it. I think this is a whole area we need to work on as a community.
Well, I think things like x86 and ARM processors are very general purpose and just bad at everything. And then the GPUs are good at some things. The question is, what does the application actually need? And is that hardware available somewhere, or can we design it?
Yeah, so you're right. I mean, not just what kind of hardware it needs, and within even what it hardware needs, what is the optimal way to schedule that job? I think that's where what Semantica you are saying scheduling comes in picture,
Yes,
right?
yes, yes. Yeah.
I mean, you may have a cache locality, you may have a cache line alignment for a given job, right? And you want to keep it within those cache boundaries within the CPU subsystem, right? GPUs don't help you there. So I mean, it's a open field, and that's something which we are grappling with. The moment you kind of create these massive scale system of systems, right?
There's a kind of methodology I'm trying to get the guys in the Open Ethernet sort of group to do, which is like you start off with your application running as a pile of containers, and then you want to move the containers around until they're on their best hardware, and then you want to shortcut all the networking stuff to make it go as fast as possible.
You're right.
Yeah, I
Okay.
think essentially we are trying to solve the problem is you have a network of a compute task, right? Then you have a network of resource. And then how do we map in between these two networks to get the maximum performance, right? That's the problem we need to solve.
Yeah.
Right.
Yeah.
Right.
And utilization, right? No one's going to buy such systems if 25% of the time, about 25% of your system is sitting unused, right? Because, we didn't map it correctly, or it's not the right size of the mini system, etc.
That may
Yeah, that's
depend
right.
on the
So-
power costs for doing that.
Oh, yeah, exactly. So I think
Yeah, the
there's
mapping itself certainly will solve the, let's say, the communication bottleneck and also the resource utilization. If you get a, let's say, perfect match, right? Ideally, so that everything was limited by the nature of the compute task itself rather than the system, right? That's
Yeah.
the kind of the goal we
So
are trying to
question for
achieve.
this group, should I lean in then and maybe say like as an open call for making this successful in addition to all the pieces, having a very robust profiling or pre-profiling, or what do I want to call it? Telemetry is more running off the system, but almost like
No, you have, Samantha, you also need telemetry, right?
I know. I'm trying to see what are the right words we want to use.
Yeah,
But it's almost an
I
sorry.
would say control and management system.
That's very specific, though. We want to cover resource scheduling, resource orchestration, topology awareness, compute diversity awareness, and overall system utilize. If you think of almost like a model, a cost model that put all these vectors in and said, okay, what's the right way to map your workflow onto a system, right? I think that's what we're saying. We're almost talking about an analysis framework that takes various vectors, and that's extendable because tomorrow we may have a different vector to put in here.
Correct.
Yeah, I think we have this outline as one of the tasks for the working group. In our initial initiative, when we kick off this at the beginning of the year, I think we have the document list a few things which the
Okay, if
group
one
will
of you can
focus.
send
One
that,
of them is that.
yeah. If you can send me a pointer to that, I'll try to at least fashion a slide out of it as an, open call. This is a key area to making this work, and
Okay, I'll post the link in the chat.
Okay, all right. Okay, so then Tushar, let's talk about, I thought, this or something like this is my last slide, and I don't spend much time on it, and hand it over to what is AstraSim, and you take it on with why is AstraSim the right thing to, study the whole thing. What do you think?
Yeah, no, that sounds good. So I can also very quickly share my screen. We can see, maybe I think you can, in that last slide, like maybe I just talk for a couple of seconds and then just transition
Yeah,
over.
that's
And then,
right. Yeah.
Yeah, I will, let me share my screen. Again, I'll move this to the right template and stuff later, but I'm trying to see which screen is visible. Is it the...
Your
Can you-
your screen is your good. Yeah, we can see your main PowerPoint screen.
Okay, perfect. Yeah, so I'll just again very quickly go through this. I mean, this is just a mini version of the talk I'd given to this group a few weeks back. So, I will talk about kind of this design space, kind of going all the way from the workload through software, hardware, technology, I'm now thinking that it might be valuable to have a figure of the system of systems again to tie it into this. But anyway, so this, how do you navigate and co-optimize? So that's where AstraSim comes in, key pieces, AstraSim, the APIs, custom simulators, the Chakra interface, and then kind of walk through some of the design principles. And just very quickly, I think I'll talk briefly about Chakra, what the vision there is. Might have to cut some things here, but and then like just go through each of the layers, specifying collective algorithm, system layer, compute layer, network layer, so on and so forth. Brief like toy cartoon example, summary, some external engagements on the ML Commons side, and like generally the open source. And I was thinking I'll talk, maybe I could, this is a slide I might edit a little bit and make it more into a call for action. So I wanted to mention a few developments, but I think part of my intent was also to use this as a call out to, Kingshuk's talk later, which will talk a little bit about just, kind of a mechanism to describe these different AI platforms, which can then become like a front end to tools like this to set it up. So that was my intent essentially. Yeah. So happy to kind of get any thoughts, feedback, especially kind of thoughts to tie it to the system of systems view or the next talk from Jasha. I'm not sure if actually, because Jasha, you'll come next. I'm curious if there are things you want me to talk about to help your talk, or would this level of detail be sufficient?
I think they would definitely be fine. I mean, we'll talk about the kind of co-evolution algorithms we've been running, where like it's good that they've seen AstraSim before. That's definitely helpful.
Got
But
it.
there's nothing specific you have to say about it except for that. If at the end of your talk they know that you can run a workload and simulate how quick it would run or like how long it would take, and the simulator gives you some rough numbers, then that's all they need to know. Really, from mine.
One question I have for Tushar is that in this AstraSim model, we have the capability of different, let's say, the CPU vendors or different hardware vendor to come in and plug in their simulators.
Yes.
And
So
get the rest of the performance or the benchmarking or other stuff done.
yes, yeah. So I didn't go into that in detail. Sorry, continue to share. But basically, I hope my screen is still visible, right? Yeah. So essentially, Prakash, I think the let me come back to this. So, sorry. So in some sense, the compute, my bad. Yeah. So this compute layer is where this piece comes in. So via the compute API, you can plug in different compute models. So this is kind of where proprietary compute simulators can be plugged in. Yeah. So I actually, maybe I have a slide which I had commented out, but I might actually just show that, I think, because that might.
And it may not be the totally proprietary, because RISC-V architecture is
Not about
like
proprietary. Sorry, I just meant that extra. So I think just to kind of clarify. So the whole idea in AstraSim is that you plug in your own simulators for compute memory network. So yes, you could plug in your own simulator via an API and network simulator via an API. And so today we do that. For example, I mean, I was going to give an example for network. How we are today supporting several simulators, and similarly for compute also, maybe I'll just flash that slide that you can plug in different compute simulators. Yeah, so that's the idea.
QMO already integrated?
No. So first, let me kind of again add that so the compute simulator part is I would say that in the infrastructure right now, I think the network simulation piece is probably the most robust. The compute simulator piece is where we are, adding some more support. But at a high level, the idea is that, so if you kind of think about the broad goal here, the compute simulator is giving you a compute time for running that operator, and the network simulator is similarly simulating the network operators, and ultimately AstraSim is putting everything together to understand how much overlap you can get. So with that in mind, I would say that to that question about is QMU supported, I would say that's the job of the compute simulator. So AstraSim's job is to just tell you this is the compute operator to run. And now it's the job of the compute simulator to kind of model it in whatever fidelity. You want to use a roofline, or do you want to kind of model like a full detailed, cycle level simulation with like functional and timing and so on? Like, that's really up to the compute simulator, if that makes sense. Yeah.
Okay.
Similarly, for the network simulator, you can have a very simple analytical model, or you could plug in an HT-Sim or an NS3, like depending on the level of detail and fidelity you want to model. AstroSim's job is to expose this API through which we kind of give the support to just, call external tools from this. As long as you instantiate the API and implement a couple of these functions, you can now start calling external simulators. That's the idea. Yeah.
So two things, Tushar, as you kind of go through and we jump to Yasha in terms of that. I would like you to stress in terms of this being pluggable. So as you
Yes.
talk about compute models, so it's an extensible simulator space, number one, through Chakra real traces or being able to build synthetic traces in terms of what you're saying. But it's a pluggable, it allows for black box kinds of things, but then also connect to your FTS. Lightning talk,
yes,
talking
yes.
about an actual real world network simulation thing that you're doing with the HPE team. So
Yes,
make your
yes.
own connection to you. So make sure
That's a
that
good point.
I don't have to tell you to speak
Yeah.
up for yourself, but that would be great because
Yeah.
that really emphasizes the pluggability and extensibility.
Yeah, makes sense. And there was one question I wanted to clarify. So Samantik, I remember you mentioned about SST. I've actually been curious. Like, so I guess there is a version that you guys have with SST plugged in. So one question was, in this network simulator piece, should I add SST as a row for kind of completeness and continuity from what you mentioned? And I guess a related question was, then people would be asking about, is that in the public domain yet? I guess the answer is no. So just wanted to.
Yeah, I mean, I don't think we would put our SST network models into the public domain, Tushar. We are
Yep.
certainly looking at integrating SST with Astrosim,
Right.
right?
Fair enough. Yes.
Tushar and the rest of the team, especially because of this last comment, and that certain things are proprietary and not going to be open cloud or such. What is the main intention of simulating these things? What is the input parameters and what is the expected outcome after one simulates these things? What will one learn?
So, go ahead.
Go ahead, Jack. Yeah.
Yeah, so the thing is, as we were talking about kind of the polymorphic space, there's been an interest as we start to look at this, and this may be where we can connect back to your supercluster builder. But as we start to look at these spaces, like Jay talked about, can we discover a topology? Can we look at things? Now we can actually build different topologies, running a trace, understanding some things, and looking at how does it impact latency? How does a different compute model? So it allows us to actually go ahead and understand some of the trade-offs around topology, workloads, compute elements, configurations. Today, in terms of some of the AI training, Tushar has some things around collective communication kinds of things, looking at different ways to do some of the network aspects. But as you start to look and say, could I look at, for this given discovered topology or these things that we're actually going to go ahead and build, what would be the impact of picking A versus B versus C? And it does connect to the Chakra, to the ML Commons, things like that. And we're looking to extend this not only from training, but Tushar and I are talking to Oana about, as we start to look at inference and different kinds of aspects around inference and some of the other services that would come, which are much more inference related, what kinds of things could we do?
And just to add to that, I think to what Samakas, I think in terms of, I'll also view that as feedback for my slides. I'll try to make sure that I have a very clear thing about, like, these are the inputs going in and these are the outputs. But and I think to answer your question in some sense, like the inputs are, the workload goes in like parameters for. So because I mentioned like this design space, so you have inputs for the workload layer, the system layer, the network, the compute memory, all of them go in and as inputs. Some of them are technically inputs to AstroSim, some of them are inputs to the simulators that are plugged in. And ultimately you get outputs which are, again, kind of across the stack, right? Like the end-to-end for the workload and individual statistics for the components that were plugged in, if that's kind of the high level idea.
To model the workload, as you just said, is it trace-based? Is captured based on real systems? Is it algorithmic? Is it envisioned? Is it AI generated?
Apologies for not going into that, because as I said, I gave a talk on all of that here. So the intent was just to give you, but let me give you a quick sense. So I guess it's all of these. So that's where this whole chakra effort comes in. So we have this effort with ML Commons where we are creating a standard like schema to describe distributed AI workloads. So it's a graph-based representation. Now, how do you get that graph? You could collect it from a real system. So we have support in PyTorch for that, like through that working group, or you could create it synthetically as well. So there's kind of different mechanisms to get that. So the simulator AstraSim, the idea is that its API is that format, again, kind of emphasizing the plug and play nature. And the way you get that workload input is, again, real systems or like synthetically, like there's different ways with which you could do that. And as long as you generate it in that format, the simulator will accept it and simulate it, if that makes sense.
Tushar, quick clarification. Eric reminded me it would help to have you point out SST and AstraSim integration. There are a lot of open SST models. There's Merlin, which is a so and there are several other national labs as well.
Exactly. So I think my hope, and actually that's how we've done even with some of the NS3 models and stuff. My hope is that in the public version of AstraSim, we create, so the way we typically do it is on the public version of AstraSim just has like a header file for whatever backend is there, and then you clone whatever like the actual repositories, right? So like HP could be cloning like an internal proprietary SSD repository, but an external user could be cloning like a public SSD. That's the same thing that we've done with HTSIM. Like there's a proprietary version and a public version. I think Marvell kind of just pushed like the interface file so that anybody could clone the public version and run it. So I will put that in. I think it's not released yet, but I think if there's a question, we can say that, we'll work on trying to get that released so that it can work with the public version. But SST, because that's a question I get every time. I think there's a lot of people interested in the SST public version of SST running with this. Yeah.
Do you support TensorFlow in addition to PyTorch?
In the Chakra infrastructure, no. And I guess it's just, today, no. I think I will say that a lot of the support in PyTorch has come from Meta and now NVIDIA, and they just are using PyTorch. So that's been the reason. And kind of, I guess, Google has not had, Google is kind of interested, but there's nobody who's contributed that piece to the Chakra ecosystem yet, either for TensorFlow or JAX. Yeah. So yeah, I was going to say, I think wearing that hat, if somebody wants to help collect these traces from TensorFlow, that would be great. That would be a really, really valuable outcome as well. But so far, I'm not aware of anybody doing that. Yeah.
Okay, so we're gonna give Yasha 5 minutes here, but I just pinged Weifeng in chat and said, as we kind of look at this perspective that we're talking about doing in terms of system to systems topology, kind of the observability, the traces, the perspective, things like that. We'll see if we can add kind of a clarification to the blog so people come, okay, I see how these things and why these things are connected and why, so we can see what we can do to set the tone before we jump in, but we'll try that. So Yasha, you want to kind of walk through, sorry, and then we'll see what we can do to find a place where we build all the slides and we can do it on Google Drive or Semantica, Tushar, Yasha, and Winston, work offline to build the deck if you want, and Jay, we just have to make sure we connect some dots.
Yeah. So, well, Jack, should I take over? Is that good?
Yeah. Yes, go ahead.
Yeah. Yes, please.
Nobody. Okay,
yes,
cool.
please.
I mean, so the slides are provided in PowerPoint, so I suppose it's probably easiest for everybody to just build offline and then reintegrate afterwards. So just to keep this brief, I mean, so I gave a update including slides on the work that we've been doing 2 weeks ago, and that's actually available on the drive. So if somebody missed that session, that was obviously recorded, and so I'm not going to run through the details and slides in this case. Obviously, for me, the important thing is to link nicely to Semantica. So it was quite good to see now what they're roughly planning. So essentially what I suggest, Semantica and I'm going to meet one-on-one, I think, to really iron out how these two things fit together. Just as a quick feedback. I think what would help, because it does obviously become a bit of a chunky, long-ish slot now, with the 40 minutes. I think it's probably quite good if, like, in Semantica's part, we would include, like, start out with, like, essentially slides on the challenges. Like, first of all, summarize the goal, like, very concisely, briefly, and then kind of highlight what are the challenges, and then highlight that the different parts of the talk are going to tackle the different challenges, right? We could highlight that, like, having a simulator is a challenge, and then having the algorithms for the co-design is a challenge, having the protocol, having the schema is a challenge, and kind of, and then that obviously we could highlight challenges too, which aren't tackled by the working group yet. But I think that at the start already gives people a bit of a, like, okay, what's to come, and kind of gives them a bit of a cohesive narrative throughout. And then Semantica can go into all her, like, the workloads and stuff she discussed, and I think that all works well. My goal would then obviously to fill in everything which is related to algorithm co-design. So that is essentially, you know, to summarize in probably 2 sentences, is that we both analyze in shape the graphs of the algorithms and also the hardware through a co-design process. So we can essentially change the algorithm workload, but also make at least some changes to the hardware and make sure that they fit. Obviously, this is within certain constraints, but so it actually brought up somebody earlier, I think Jay actually said it, that the important thing is here to analyze the workload graph, topology, etc. So this is actually all covered by the algorithm section here. So we run people through it. And yeah, the hope for my talk is I actually kind of still reason through whether it's better to do, like, what piece to put in which order, but I'll run through this in the next week and then sync with Semantica on this. But yeah, so essentially the idea is Semantica sets out the entire challenge and what's the goal state, and then Tushar can come in and introduce the simulator, and I hopefully give people a good feeling for actually, if they, you know, at least wanted to get going with this and design, you know, what an outline of a cluster should look like, or which algorithm should run on this cluster. They can use at least some of the algorithms we've developed. They're obviously not completely ready for the summit, but, like, there's a decent beta version of all of them done. And then yeah, that's kind of my outline. I think in order to not run over 7 today, I think I'm probably going to leave it at that, but obviously happy to take questions now or offline. But yeah, I think Semantica and I think it's probably best if we find half an hour and just kind of really make sure that the narrative is fluent through there. But I'm, you know, from what you've presented, I'm quite confident we can make a nice transition there. Good. So that's what I had said to say. Maybe I now did too quick and we have 8 minutes left.
I think that works out, Yasha. You know, yeah, so working out kind of the messaging and in terms of that, I think is really key. And, you know, as you said, I apologize. As you said, it's a little clunky, you know, with the longer session, but it was the only way I could absorb.
No, I think it's good. Honestly, I think it's not clunky per se. It's more like it could be clunky if we don't manage it well. I think this is actually kind of what I wanted to say. So I think it is a great opportunity to provide people with a good overall narrative. But I think to build a good overall narrative, like at the start, they have to be told, what are the challenges? What has the working group been working on? How does this all fit together? And I think ideally, obviously, wrap all of this up with a nice call to action. You know, Tushar has his own call to action. Like, I think there maybe even is a point here where maybe we should move to Tushar's call to action, not into his slide, but maybe actually put it at the end of mine, where we kind of collectively put all the call to actions at the end of my slides and kind of be like, this is what the working group has been doing. This is our larger vision for systems of systems across these organizations that we're part of. You know, how could you help? You know, like, I think that would be quite nice actually if we could wrap up like that. And
Actually,
you know, then it has a whole kind of overall.
That'll have to come after Winston or Kinshuk's talk, right?
So
after yours will be, and in fact, I think Winston, you do.
Exactly. Sorry.
Yeah. So I think you know, like I think with this infra.proto stuff, right? I think I said it multiple times. It's kind of like table. I mean, it's like salt and pepper, right? On its own, it's not interesting. But it does actually provide the sort of like the needed context, right? That enables co-design across different systems, different components, and different software layers or stack or applications. So I think, you know, I'm also talking out loud, right? We don't have slides, and because it's salt and pepper, right? I want to understand more in terms of the main sort of use cases, right? Yasha and also Semantica is going to be describing, because I saw already in Semantica's slides, you have some graphs, right, about systems. And I'm sure Yasha, you'll come to some graphs in your slides too. And my thinking
There
is
will be
at the
graphs.
end, right? Yeah, we will come in and basically, let people know that, hey, when you talk about graphs, really like we need a common machine parsable definitions to describe the underlying physical system, so you could actually do all these things, right? And optimize in the common language. And that's really the key, right? And then I could tie that then along with the, what Tushar mentioned earlier, as this is going to be the topological input, right, into the simulation that can enable us to do all these explorations, right? And that's how how I envision is going to tie it together, right? Really try to support what you guys want to illustrate and then call out to people. Right now there is no common language in that layer, right? That's machine parsable, that you could actually enable multiple optimization across the stack. That's essentially it. So
Yeah, I'm trying to get the guys who are doing the Open Ethernet stuff to do a network description language, so we can sort of blend the compute and the networking together. But I'm getting a bit of resistance there.
Guys, since you have thought through all of these topologies and eventually realized the graph is the best method to describe these topologies, I'm just wondering, why is it that the traditional netlist definition that everybody uses to describe how things are interconnected to build systems is not useful here, is not sufficient here?
Which are you talking about, hardware description languages?
Yes.
They don't have data pipes. Basically, you're trying to pipe data from one place to another in asynchronous ways in software, but the hardware description languages don't have those constructs. I tried adding them in System Verilog and got a lot of pushback.
Exactly, yes. So you start with, used to be schematics, and then high-level languages such as Verilog or VHDL came about and said, okay, I have a device that has so many ports, input ports, output ports connected to all of that, describe, and then you run things, behavioral models and stuff, and voila. Why is it that we have to do something new?
You don't really need to do very much new. Since I didn't get it in System Verilog, I did a C++ thing that supports it.
I mean, I don't think it's about, I don't think this thing is about, I would say, like, how do you say it? I think the key is, I think we need people to realize that co-design involves everybody from different stack with different domain and knowledge and expertise. And there's different sort of flavors of language, right? From different sort of, engineering contexts. And I think the key here is like calling out that like we need a common language somehow, right? And then maybe
I think you can skip that, and you can just change your understanding of the existing languages.
So, I'm saying, it's only 5 minutes, right? It's not about pitching, or evaluating the merits of one versus another, make it into a BI versus Emacs thing, right? I think there's really a challenge, right, in terms of how do you describe the system?
Yeah, there's a granularity.
Maybe what Sean mentioned might be Infra.Pro, might be something else, but
there's a granularity thing where you're looking at routines and modules and hardware description languages, and you can do routines and modules in all sorts of different languages. The question is, what's the communication between them, and is that, can you sort of treat that in some more common way? And I would say that you probably can, because the interfaces on routines and module things are pretty easy and understandable.
So as you're describing it, I'm a hardware guy, right? So if you tell me that we can take advantage of the methods to describe how devices are interconnected using a netlist or Verilog or such, but then we're missing the pipe and data transport between these, and therefore this is what we're going to add, and using these common methodologies you're making, that's a very easy thing to describe and tell people, and people will see the value of that.
And so, Shamik, I think we're seeing kind of that evolve as well, because, you know, when Winston was doing the presentation for Open Systems for AI, like, well, why can't you use Redfish, or why can't we use this? And it's like, well, you know, we can connect to it, but we can't, you know, there's limitations to that. And then somebody said, well, we do things in terms of open config because Redfish couldn't extend into network. And then the open config space basically said, well, we don't want to bend in terms of some things. So I think what we ended up with is it gives us a way to interconnect some of the things without replacing. This isn't a whole net new, but it allows us to say, okay, when we describe this and we describe the topology and some of the elements, we still have to connect to other things. So if to your point, if there's a hardware thing we connect to, what are we going to do? And what are some of the things as we start to talk about the traces, the traffic, the data, some of the elements when we're connecting our data services to our topology, to our compute elements, as we build it up and understand some of the system elements around it. But I think Winston was pretty clear with the overall group. We're not looking to replace anything, but find a way that we can actually represent it using some of the elements we have today. And so if Netlist is something from your perspective, from a hardware point of view, we definitely can have the dialogue of how do we connect to that and what can we do to augment it.
Okay.
So, Jack, there is already effort on IEEE and national labs about system of systems. This is something people have been talking about it for a long time. What is new here in this proposal, aside from what we have seen, national labs, research labs, and IEEE, and many other
Okay.
consortia?
Yeah, so we'll have to take that question. I know Semantica had to drop, but
Yeah,
you know,
exactly.
so
You have to talk to her. You have to talk to her. You're right. You're right.
Okay, because I know she's been working with the Lano folks and some of the other labs on this particular space as we move from monolithic systems. You know, if
Yeah.
you think of HPC used to be a much more monolithic system, and I'm going to look. Matt's not on either. Oh, Mike's on. So Mike, correct me where I go wrong. But you know, we've been moving from monolithic to a much more composable HPC and handling workloads. And so this construct allows us to handle some of those things as we start to go into that space. And so this isn't like, hey, we're going to build systems differently, but how do we use, and as Semantica said, how do we become much more efficient of how we do it? And if we do have a way to model it, we can understand, you know, where do we make trade-offs? What's the impact of doing some pieces and doing some of those things? And from what I understand, so Yasha, I know you're still on. When you get together with Semantica and we kind of run by with Jay and Tushar and Winston, you know, what's the message? So if there's like a couple of sentences as we go through that we can add to the blog saying, hey, you know, we're going to bring this perspective, you know, so through the blog, here's what we're telling you, you know, here's what we're going to tell you. And now we go through and say, here's what we're telling you. And then we kind of go through and kind of reinforce that message. And then to your point in the call to action, here's what we told you, and here's how we'd like you to join. And then I think, Shamik, we can talk about this isn't a replacement and we're starting net new, which obviously forces us to tilt at a few windmills we don't want to, but how do we work together in the call to action?
Thank you.
It's Jack, Semantica will be in the Global Summit, OCP Global Summit.
Yeah, she's presenting first.
Oh,
She and Matt are co-presenting the slides she showed today, which leads into Tushar to talk about the model, which leads into Yasha talking about the application of a model, which leads into Winston and team or Kingshuk talking about, and oh, by the way, here's the way we're looking to connect some of the existing languages that we have today to now actually describe this in terms of infra.proto. So what we need to do, Prakash has some things he'd like to add in terms of the overall mission of the group and how do we kind of crisp up that message. And I know we're running over and I apologize for that, but
so Jack, which because I will be in the Global Summit, which session is this? I need to attend.
Wednesday morning, 8 to 8:40.
Wednesday morning, excellent.
Okay.
And what is the title? What is the session name?
So it's under OCP Server, OCP NIC, HPC, AI hardware, software breakout. So if you just
Excellent.
find that in the schedule, you know, where you find those things gang together, click on it and it'll show you. Today it's 2 sessions, but we're gonna actually kind of, we're gonna connect them so it becomes one cohesive thread where we kind of connect all the dots. So
That's great. You will be there, Jack?
I am not traveling, no.
Oh man, why not?
I don't speak, I don't travel, and there's no budget, so.
Okay. Anyway, thank you very much. I will look it up.
Okay, all right. So
Thank you.
yeah, if you could work on kind of that 2 or 3 sentences and
Yep.
Weifeng, how do we connect that back to the overall, as you mentioned, the overall work thread in terms of that? And then everybody should have access to kind of the draft. I just converted to Word, so I'm going to post it in Word so people can edit however they'd like. Okay.
Hey, Jack,
Sounds
do we
good.
have a
Thanks.
timeline, like when we need to finish this?
So slides have to be in for review August 25th.
What about the blog?
It's really up to us, but once we finish the slides in August 25th, because it has to, same thing as last year, it has to go in for review. And then that gets us into September, and we'd like to hopefully have it posted mid-September, which gives us a month to do our social media, whatever we want to do.
Okay, great.
Okay. All right. Thanks, everybody.
Thanks
Thank
all.
you. Thank you very much.
Bye-bye.
Okay, bye.